Welcome to Lesson 3 of Chapter 2 on Linear Models and Applications. Basically, this section is just going to be word problems, is what you'll recognize these as. And we are going to be writing and solving these linear equations that model real-world situations. And then I'll start with also giving you a formula relating to some application in the real world, and you'll be solving that formula for whatever variables we are interested in. So let's go ahead and get started. So here's just a 5-step general way of solving these real-world problems and coming up with a linear model that fits it. So the first thing you want to do is to identify any quantities that you know. You're going to identify those. You will assign a variable to represent an unknown quantity or any unknown quantities. If you have more than one unknown, then you want to be able to write the second unknown in terms of the first, so that you're only solving for one thing. And then we're going to go ahead and write an equation where we change the words from English into mathematical terms or into algebra, and then we're going to go ahead and solve the equation. So the rest of this will be examples for you. So here's an example with two cell phone companies. They have different packages they offer. One of them offers a monthly service fee of $34 and then 5 cents a minute for every minute. The other company offers a service fee of $40 and 4 cents a minute. So the first question says, write a linear equation that models the packages offered by both companies. So company A, you have a $34 flat rate, and then the thing that varies is the 5 cents a minute. So for company A, we're going to have 0.05 times x, where x is the number of minutes, and then we're going to add to that the $34 flat rate fee. So company B, you should be able to figure this one out then, is going to be 0.04 times x plus 40. Part 2 says if the average number of minutes used each month is 1,160, which company is a better plan? So what they're saying here is substitute in the number of minutes, 1,160, in for your variable x, the number of minutes, and see what you get out. So company A, we end up getting $92 is what it costs us. Company B, when we substitute in, is $86.40. So the better plan for that number of minutes is clearly company B. Part 3, if the average number of minutes is 420, which company offers the better deal? Same kind of thing. We're going to just use exactly what we did in number 2 here, but we're going to substitute in 420. So using 420 in for x, we get $55. Using 420 for x for company B, we get $56.80. So this time, company A is a better deal. It's a little bit less money. Number 4 says, how many minutes of talk time would yield equal monthly statements from both companies? The question is asking us, where are these two equal? How many minutes would they be the same cost? So let's go ahead and set them equal. If we have 0.05x plus 34, that's company A's fee, setting that equal to company B's fee. And then we're going to go ahead and solve this for x. Okay? So subtracting 0.04x from both sides and then subtracting 34 gives us 0.01x is equal to 6, and x equals 600 minutes. Suppose we have the perimeter of a rectangle being 54 feet, and we know the length is 3 feet greater than the width. What are the dimensions of the patio? So in our patio, we're going to call, it's a rectangle, so I went ahead and drew a picture for you here. We have the width being W, and it tells us the length is, that means L equals, is means equals, 3 feet greater than. So it's 3 plus the width. So there's the dimension of your length. And the formula for perimeter is twice the length plus twice the width. So now we have both of our length and width in terms of the width. So this is where we had two variables, but we want to write one of them in terms of the other. So let's go ahead and solve this for W. So our perimeter is 54. Here we substitute in W plus 3 for anytime we see the letter L, and then plus 2W, distributing our 2, adding like terms, and then solving for W, we end up with W equals 12. So we know the width is 12, so now we should be able to calculate the length as well because that's only 3 feet longer. So that gives us a length of 15. In the second example here, we have the perimeter of a table, or excuse me, of a tablet of graph papers, 48 inches. Length is 6 more than the width. Find the area. So again, we have the perimeter is twice the length plus the width, and we know that the perimeter is 48. We know that the length is 6 more than the width. So we're going to substitute in for L here, 6 plus W. So 48 for our perimeter, 6 plus W for our length. Distributive property, gather your like terms, and get your variable alone and solve. We get the width is equal to 9. So if the width is 9, that tells us that the length is 6 more than that, which is 15. Now we're looking for the area of the graph. The area of a rectangle's length times width, so we need to multiply those two, and we get 135 square inches. Last example here. It takes Andrew 30 minutes to drive to work in the morning. He drives home using the same route, but takes 10 minutes longer, and he averages 10 miles per hour less than in the morning. How far does Andrew drive to work? We're looking for the distance, right? We're looking for how far he drives. So we're going to write two equations, one for each trip. On his way to work, his distance is his rate times his time. Well, we don't know what his rate is, okay? But we know that his time takes 30 minutes. And we're going to write that in terms of hours. So you could use 0.5 or you could use the fraction 1/2. When he goes home, his rate is 10 miles an hour less than in the morning. So in this one, his rate is whatever his rate was in the morning minus 10. Now the 2/3 here, it takes him 10 minutes longer. If it took him 30 minutes in the morning, it's going to take him 40 minutes. And that's 40/60ths or 4/6 of an hour, which is 2/3 of an hour. And the distance is the same, to work and from work. So since that distance is the same, we set them equal to each other, and we're going to solve that for r. So here are our equations. 1/2 r equals distributing, I think I missed a thing here, equals r minus 10 times 2/3. Distributing our 2/3 through the parentheses, we have this. And then gathering our like terms, we subtract 2/3 r from both sides. Getting like denominators on the left, we end up with minus 1/6 r. This would be 3/6 minus 4/6, which is minus 1/6. And multiplying by the reciprocal of negative 6 over 1, we end up with r equals negative 20/3 times negative 6, which gives us 40. So now we know his rate, but that's not what we're looking for. We're looking for the distance. So the distance is the rate times time, which gives us 20. That's it for this video. See you next time.